An elliptical arch is 8 feet wide at the base and 14 feet tall in the middle. So this is a pretty long, skinny elliptical arch. The other side is underneath whatever roadway we have. This is just the top half. 8 feet wide and 14 feet tall. We want to find an equation for the ellipse. Now the equation of an ellipse is x minus h quantity squared over a squared or b squared plus y minus k squared over the other one equals 1. In this case, this is a taller one, so the a squared would be under the y term and the b squared would be under the x term. In general, the a is the longest distance. In this case, it's the y distance. We need to determine the center. Now, superimposing a coordinate system in here, we could do this in lots of different ways, but having the center of the ellipse be the origin of the coordinate system is the most convenient. With that information there, we now have 0, 0 being the center, this point being 0, 14. That gives us a equals 14. And this point would be, since the whole width is 8, this is 4 to the right and then 4 to the left. So this, now we have the center, we have a equals 4, we have b, sorry, a is 14, b is 4. There's no information about the focus in this problem. We don't need it unless they ask for it. Assume that the ground is the x-axis, that was good, and the arch is symmetric with respect to the y-axis. So that is actually information that tells us what I assumed would be the easiest anyway. Then use your equation to find the height of the arch exactly 1 foot from the base of the arch, not from the center. So I'm looking for 1, 2, 3, this point right there. This is the point that we're looking for. It is 3, I'm going to put h. Oh, no, not h. 3, height of the arch. We have x, we have h, we have y. I'm just going to use question mark. All right. Let's see how far we can get into this problem. First off, x minus h. H is 0. So the x minus h is just x squared over b squared. That's 16. Plus y minus k being 0, that's just y squared over a squared. Now 14 squared, we would work that out. It is 196. So we have the full standard form of this ellipse. So we can plug in 3 for x and solve for y to get the question mark that we're after. Let's see what that looks like. 3 squared over 16 plus y squared over 196 equals 1. Now, because they're asking for the answer to 2 decimal places, I don't need to be as specific before using my calculator. I don't want to do any rounding errors, but I can start my calculator soon. So the equation we have x squared over 16 plus y squared over 196 equals 1. And now if we pull up a calculator, to make my calculator a little smaller. There we go. Who knows what's on there? Math, figures. We're going to do 1 minus this term, which is 9/16. So we now have y squared over 196 equals 0.4375. That's an exact number. I'm not rounding if I were to write that. Y squared over 196 equals 0.4375. multiplying by 196. Y squared equals 85.75. And then we can square root that. Square root the answer. And our answer would be plus or minus 9.26. This is now approximately. The reason for the plus minus is there's actually a point below that satisfies the equation of the ellipse that's 3 feet to the right of the center, 1 foot from the edge. But we're not interested in that one. We're interested in the height above this surface. So 9.26 would be our final answer. Height 1 foot. Let's give it a unit story answer, foot. If we had a little bit worse luck, let's say I had this number and then I had to multiply by 196, or some number that goes on longer, like if I had 1/3, I wouldn't want to use 0.3333 here because it's all of the data. So instead I would take that and multiply by 196, and it still goes forever, and then I would square root that. I would hold myself from rounding anything, leaving it all in the calculator. We got lucky with these decimals being finite and we could write them all down, but if they were infinite, don't round. You can write down a rounded answer, just don't use it. Keep using full precision. All right.